model building. Up to this point, we've been preparing, looking at data, understanding variables, shaping features. Now we reach the part most people think is the beginning, model building. This is where data turns into decisions, where patterns turn into prediction, where the system actually starts doing something. But here's the truth: model building is not magic. It's not intelligence in the way people imagine. It's structured decision making at scale. Let's slow that down. A model is just a system that learns relationships. It looks at data, finds patterns, and uses those patterns to make predictions. That's it. No awareness, no understanding, no intention. Just pattern recognition. But when done correctly, that pattern recognition becomes powerful. Now, think about everything we have covered so far. Univariate analysis helped you understand individual variables. Multivariate analysis showed you relationships. Feature engineering shaped your design data into something meaningful. Model building uses all of that. If you skip those steps, your model is weak. If you did them properly, your model becomes reliable. So, model building is not the first step, it's the result of everything you build before it. Now, let's talk about types of models. There are many, but at a high level, most problems fall into two categories: classification and regression. Classification is about categories. For example, is this email spam or not? Does this patient have a disease or not? Regression is about continuous values. For example, predicting price, predicting temperature, predicting risk score. Different problems, different models. But the underlying idea is the same: learn from data, then generalize. Now, here's where things get interesting. A model doesn't know anything, it doesn't understand your problem. It just learns patterns from the data you've given it. So, if your data is flawed, your model will be flawed. This is one of the biggest misconceptions in AI. People think better models fix bad data. They don't, they amplify it. Now, let's talk about training. Training a model means showing it examples. You give it inputs, which means features, outputs, labels, and the model tries to learn the relationship between them. It adjusts itself again and again until it minimizes error. This process is optimization. The model is trying to get better at predicting, but better doesn't always mean correct because a model can learn too much. This is called overfitting. Overfitting happens when a model memorizes the data instead of learning the underlying pattern. It performs perfectly on training data but fails on new data. And this is a critical point because the goal is not to memorize, the goal is to generalize, to perform well on data the model has never seen before. And that's harder. That requires balance. Not too simple, not too complex. Just enough to capture the real pattern. Now let's talk about evaluation. How do you know if your model is too good? You test it. You split your data, the training set, the testing set. You train on one, you test on the other. This tells you how well your model generalizes. Now, depending on your problem, you use different matrices. For classification, accuracy, precision, recall, F1 score. For regression, mean squared error, R squared. These matrices help you measure performance. But here's something important: matrices don't tell the full story. A model can have high accuracy and still be useless. For example, if 95% of your data is no disease, a model that always predicts no disease will have 95% accuracy. but it completely fails at detecting the actual cases. So you need to think beyond numbers. You need to understand context. Now let's connect this back to AI. When people say AI made this decision, what they really mean is a model predicted an outcome based on patterns in data. That's very different from understanding because the model doesn't know why. It doesn't question itself. It doesn't reflect. It just outputs. And that's why explainability matters. Because if you don't understand how your model works, you're trusting something blindly. And blind trust in systems is always risky. Now think about scale. AI models today operate at massive scale. Millions of predictions, billions of data points, and small errors at that scale becomes significant. So model building is not just technical, it's responsibility. Because the decision your model makes can affect real people. Now let's bring this back to you. Model building teaches something deeper. It teaches you that decisions are based on patterns in data, in behavior, in life. If you don't understand the patterns, you don't understand the outcome. And if you don't question the patterns, you repeat mistakes. So, building models is not just about prediction, it's about understanding systems, how inputs become outputs, how structure shapes results. And that awareness is what separates someone who uses AI from someone who understands it. So, next time you build a model, don't just focus on performance. Ask yourself, what is this model actually learning? Because whatever it learns, that that's what it will repeat, and that determines everything.